Alrighty, this is going to page 55 and we're done. It's the rational zero theorem, which can also be called the rational root theorem. Same thing either way because zeros and roots are the same thing. Let's talk about what rational zeros are first. It says recall that a polynomial function of degree n, so polynomial degree n, can have at most blank real zeros. So if I have a polynomial of degree n, what's the most real zeros it can have? N. Very good. So real zeros, meaning not the complex ones, can be rational or irrational. So what's the difference between a rational and an irrational number? Or can you give me examples of either one of them? What's it? What? 1. Would 1 be rational or irrational? 1 would be rational. Okay. Square root of -1, what would that be? It's actually imaginary. It's like a different little category, but yes, it's complex. Okay, so we're not talking complex though, so I don't want you to get that confused. You don't have to worry about the negatives of the complex, the imaginary. Those are the ones that aren't our real zeros. Okay, so yes, those are a different type of thing. But rational is just a different form of what word? What rational? What's the root of that word? Ratio or rate, right? They all go together. So what's a ratio in math? You need to put that away, please. What's a ratio in math? A fraction, okay? So if I can write the number as a fraction, as a comparison of two numbers, then it's a rational number. If I can't, then it's not. So what's an example of an irrational number? It's a number I can't write as a fraction. Okay, square root on the bottom or even on the top, because you're thinking of rationalizing the denominator, which is right, that's good with those words. But square root of 2, right? If you get the decimal for that on your calculator, can you do math enter and it gives you the fraction back? No, right? You just think, oh, what's wrong, right? Well, it's because you can't write it as a ratio. A square root that can't be simplified, or, that is not, a square root of 4 obviously is a rational number, but if it has to remain as a square root, then that is irrational, okay? And there's other forms that pi is an irrational number, right? There's not a fraction that actually gives you that actual value. So rational zeros or rational in general are those that can be written in the form of a fraction, okay? Because ratio should always make you think fraction mathematically. And your example here would be like P over Q, it's P and Q. So our rational zero theorem can be used to determine all possible rational zeros of a polynomial function. This is good because it gives us a starting place. So I want to remind you of what we were doing last week. If you look at this was an example off of your notes from last week where I gave you the polynomial and I gave you one of the roots and we did synthetic substitution, right? We got 0 because I told you it was one of the factors. And that's this because x minus 7 was given to you. And use this to get this part right here so that we can factor this the way. Remember that? So here we're like, oh, we can factor it, keep going. So once I got to this, instead of factoring, why didn't I just do synthetic substitution again? Do you remember? Okay. Because I could have, right? I mean, we could have. What number would you have used? Would you have known what to use? No, and that was our problem, right? We had an infinite number of things to choose from. So it was factorable. We're going to go that way instead of trying to check at the rest of them, right? Because if we have an infinite number of things to choose from, we're not going down that route. Okay, but if this wasn't factorable, we would have to still be able to do something. And that's where this rational zero theorem comes in, is it gives us our possibles. All right, so that we're not choosing from an infinite amount. We still may have to guess and test something. It's not guessing. It's testing from our possibilities, but we at least have a narrowed down set of numbers to use, okay? So it says if we have this is just a polynomial. It has integer coefficients, right? So there's no fractions in there. Integer coefficients. Then every rational zero of the function is in the following form of P over Q. And this fraction is created by the factors of the constant term, which our constant term would be a sub 0. Okay, the very last thing there without any variables on it, over the factors of the leading coefficient. That's how we figure out possibilities. And in some cases, this is much simpler than others, depending on the numbers in your polynomial. Right. So I'll explain to you what that exactly means here. If we look at number 1, it says list all the possible rational zeros of each function. So it's not all the possible zeros, but it's all the possible rational zeros. And so I've got to start with my little fraction. So my fraction, and we're going to write more out on number 1 than you have to write out on the rest of them, just so that you understand where everything's coming from. The numerator is the factors of the constant term. The constant term right here is 2. So the numerator is going to be the factors of 2 over, and then the denominator is the factors of the leading coefficient. What's your leading coefficient? The leading coefficient. Okay. So, how many factors does 2 have? Well, what 2 numbers multiply to give me 2? 1 and 2, right? It's not real hard, right? That's it. I mean, very minimal. But it could be 1 and 2. It could be negative 1 and negative, right? So my factors are plus or minus and plus or minus 2. Okay? Then in the denominator, my factors of 1 are just plus or minus 1. So then I got to narrow that down, which in this case, this one is super simple, but again, I want to make sure we understand the process here. I'm going to get my possibilities, so my possible roots, not saying that these are all of my roots, these are my possible roots. 1 over 1 is 1, so plus or minus 1, 2 over 1, and then plus or minus 2. Okay? Those are my only possibilities. So I don't have an infinite number of them to choose from when I start testing. There's only 4 to choose from to begin with. Okay, everybody good? So let's look at number 2. We're not going to write out the words here. But my numerator is the factors of the constant term, right? So I start with 18, and you can always start with 1, plus or minus 1. Then does 2 work? Does 2 divide into 18? Yes. Does 3? Yes. Does 4? Does 4 divide evenly into 18? No. 5? No. 6? Okay, so look at this. Once you get to where the middle 2 multiply to give you 18, 3 times 6, then you don't have to think about the rest of them. Just know that 2 times the next one has to be 9, and then the next one has to be 18. Okay, those are your factors of 18. Over your factors of the leading coefficient, which is just plus or minus 1. When you do this, if your leading coefficient is 1, you don't really even have to worry about your fraction because the only possibility in the denominator is 1. So basically, the factors of the constant term are your possibilities. Your leading coefficient won't always be 1, but when it is, it's just these right here, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. Okay? Any questions at this point? All right, so then let's look at number 3. My numerator is the factors of the constant term, so that's just plus or minus 1. The denominator is the factors of 4, so plus or minus 1, plus or minus 2, then 1, plus or minus 4. That's it, right? So my possibilities are plus or minus 1, then what? Plus or minus 2? Or 1 over 1 is 1, and then 1 over 2 is 1/2, and plus or minus 1/4. Be careful, because 2 and 1/2 are 2 very different things, right? And so when your constant term is 1, then your possibilities are just 1 over the factors of your leading coefficient. but I highly suggest most of you, if not all of you, actually write it down, or you're going to do ridiculous things that you know not to do just because you haven't written it down and you're not looking at it. Because there's nothing difficult about this, but it's very easy to just make a mistake because you're trying to fly through it. Okay. Questions? All right, we're going to skip number 4. It's going to go to number 5. All right, so numerator plus minus 1. You write out the factors of your numerator, or what goes in the numerator, rather. All right, y'all agree with me with the numerator? Yes. Okay. And then the denominator is going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay, everybody with me? Ask me questions if I've lost you somewhere. All right, so my possibilities. Well, I would go through and do this in an orderly fashion. I'm going to take all of the numerator over 1 first, because isn't that pretty easy? Isn't that just the numerator? So I'll just rewrite the numerator. Plus or minus 1, plus or minus 2, plus or minus 3. Then I'm going to take all of the numerator and put it over the next one, which is 2. So 1 over 2 is plus or minus 1/2, right? What's 2 over 2? 1. Do I already have it? Yes. Okay, so then I do 3 over 2. Do I already have that? No. So I need plus or minus 3/2. Then I have to do 4 over 2. Do I already have that? Yes. 6 over 2. Do I already have that? Yes. 12 over 2. Do I have that? Yes. Okay, then I do all of the numerator over 3. 1 over 3. Do I have that? No, so plus or minus 1/3. Then 2 over 3. Do I have that? No. Then 3 over 3. Do I have that? Yes. 4 over 3? No. Then 6 over 3? Yes. 12 over 3? Yes. Okay, so then 1 over 6. Do I have that? No, plus or minus 1. Then 2 over 6. Do I have that? Yes, that's 1/3. 3 over 6? Yeah, that's 1/2. 4 over 6? Yeah, that's 2/3. 6 over 6? Yes. 12 over 6? Yes. So even though you had tons of factors in that fraction, you don't have as many possibilities as you probably thought you would when you started, because some of them are double and you don't write them down twice. Okay? So remember that question of, do we have to put plus or minus? Yeah, because if not, you're going to get all kinds of lost in your numbers. All right? Plus or minus is important here to combine these. We good? All righty. So get your 6. So you work through number 6. I'll go ahead and get some of it written down, but I'll give you time to finish. Okay, so after I write them all out and I just write all the numerator over 1, that gives me 8, which is actually 16 because it's plus or minus. How many more do I write down? 2. There's 2 more, right? So what are they? Good. 1 plus or minus 1/2, and then plus or minus 3/2. Okay. Everybody good with all that? Okay. Any questions? Okay, because you're going to have to come up with your possibilities. Now, then we're going to actually find them. The directions are, or mostly the directions are right here, because I was trying to give you plenty of room to work on the back. So our step 1 is to list all possible rational zeros using the rational zero theorem. That's what we just did. Then we're going to test the zeros using synthetic substitution to figure out which ones work. And then when we find a zero that works, we can use the remainder to try to completely factor it and actually find the zeros. Okay, so we're just kind of combining this with the stuff that we've already been doing. All right, so let's look back. So first thing we're going to do is list all the possibilities. So number 7, this is good. Since your leading coefficient is 1, your fraction is going to be all over 1. So you don't even need the 18. So your possibilities, which you need to write down because it says to write them down, would be plus or minus 1, plus or minus 2. Does 3 work? Yes. 4? No. 5? No. 6 does. So that means I can jump to 9 and then 18. So this is not something that I can factor. What kind of factoring skills we have right now. That's why we need to do this. I don't have an infinite number of things to choose from. I only have 1, 2, 3, 4, 5, 6. I only have 12 possibilities because it's plus or minus. There's 12 of them. Hopefully I don't have to test all 12 of them. There's no way you need to test all 12 of them. But I need to pick something to start with, so we can start with 1. It's usually a pretty good place to start. No reason to start with the big numbers because those come out with the end part that you can actually factor if a big number does work. So we'll start with 1. Negative 27 and negative 18. For the most part, y'all did really well on synthetic substitution on the test. There are some people that are not putting their zeros for their placeholders, writing the numbers down, leaving off these lines. This gives you random numbers all over the place. That's a big factor. So, this one. All right, so is this a 0? Does 1 work? No. Did I do something wrong? That's right? Okay. All right. So then that one doesn't work. So I'm going to try negative 1. Same numbers I'm using here, 1, 3, negative 7, negative 27, negative 18. Okay, so you should be able to do this without me walking through it. So does this one work? Yes, it does. Okay, so that's good. So negative 1 works, which means that the actual factor is x what? Is it x minus 1? It's x plus 1, right? Because if the 0 is negative 1, this is x plus 1. And then I multiply that by, not by this, but by what I get from here. So that 1 is the coefficient for x to the what? 3rd, x cubed, good. Plus 2x squared minus 9x 18. Now, then I have to check to see if what I have over there I can factor. Because if I can't factor it, then I've got to go test some other things. Is that one factorable for you? Yes. Okay. So go ahead and factor that one. And then you can even go one more step after you do that, right? All right, so do we all agree with my factoring? Yes? Okay. So now that I've got it factored completely, I can get my zeros out of it. What would my smallest one be? -3. But I also have this right here, so I can do a little plus or minus 3. And then -2 and -1. There's my answer. Okay. Any questions at all? We good? So same kind of stuff, just adding little bits and pieces as we go along. We just have a list to choose from now. We're not being told, hey, this is a factor, or see if this is a factor. All right, so let's do number 8. I'm going to actually need a little fraction to get me started here. So factors of 10, plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. And the denominator, plus or minus 1, and plus or minus 3. So my possibles. I can rewrite the numerator, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Then I put all that over 3. So that's plus or minus 1/3, plus or minus 2/3, plus or minus 5/3, and plus or minus 10/3. So those are all my possibilities. Now, if you just absolutely love fractions and you want to start with the fractions, knock yourself out. But starting with the whole numbers that are smaller is probably an easier way to go. Yeah. So let's start with 1. And I'm going to divide that into 3, -8, -33, -10. Go ahead and try that one. So 1 doesn't work, right? So let's try -1. -1 doesn't work either. So neither one of those work. Move on to 2, because you don't really have another way to narrow anything down. So 3, -8, -33, -10. Bless you. This one isn't looking too pretty, or is it? I don't know. So then maybe we need to reevaluate and look at, I mean, it's fine. We could go through all of them. It could be the last 2 for all we know. But could I have just factored this by grouping to begin with? Would that work? No, it actually wouldn't, right? So this is my only option, so we keep going. All right, 2. 3, -8, -33, -10. -14. Okay. What did I do wrong?
Not that it changes the answer, but whenever you're doing -1, it's -23 instead of 22. That's what I said. Not that it changes the answer. -33 plus 11.
Oh, I see. I was like, okay, I gotcha. Okay, but that's okay. No, but it's fine. Thank you. -22, and that would have been 22, and then that's 12. Okay, no, thank you. Because if I was evaluating, that wouldn't make a difference. And so, yeah, it doesn't change what I'm doing here, but it does reassure you that I'm not perfect, like you thought I was anyway. So, all right, we did a -2 works, right? Yes? Okay, good. Everything else is right, though? Man, that's what I get for going fast. All right, so f of x is equal to, so since -2 works, the factor is x what? Plus 2, all right? And then that leaves me with 3x squared minus 14x minus 5. Now, is this something That if it factors, you can factor, like you have the skills to do that? Yes, because if not, you got to go back over there and do some more. I don't think we want to do that. So go ahead and factor that. So I've said multiple times, you factor the way you know how to factor. There's different ways, there's different little tricks or processes that you may have learned, but I need to clarify that a little bit. Factor however you want to factor, as long as it's right. Okay? There's a lot of people that you factored wrong on the test, and man, you were proud of your answer and you just kept on going, but you didn't stop to see if what you had multiplies back. You need to check yourself, because if what you have at any given step doesn't multiply back to give you what you came from, then you didn't factor it correctly, right? And then you don't want to just keep on going with that. So I know this is going to be 3x and x. My signs are opposite, and that is what you should end up with. You did grouping, or you did divide and slide, or you have some other cutesy name for whatever it is that you're doing, whatever. Okay, so f of x equals this. Got it factored all the way. So x equals, my will be -2, then -1/3, then 5. And then you should check yourself here too. These things that you have listed out need to live in here, because if they don't, something's wrong somewhere. Either your list is wrong or your answers are wrong. But this -2 is from right there, -1/3, and 5 is right here. So if you had started with fractions because you love fractions, you wouldn't have had to do as many trials, but I doubt we're ever going to actually start there. It's fine. So there we go. All right, questions? We good? All right, look at number 9. So number 9, your leading coefficient is 1. Is that nice? Yes, because that means that all we need is the factors of 30. So your possibilities here are plus or minus 1, 2, does 3 work? Yes. Does 4 work? Does 4 divide evenly into 30? No, but 5 does. And then 5 times 6 is 30. Now I can just do 10 would be the next one. And then 15, and then 30. Okay, so there are my possibilities. Now I got to start. So we'll start with 1. So I got 1, 1, -31, -61, -30. Okay, let's go ahead and try that one out. So 1 does not work. Go to -1. What do you think about -1? Does it work? Yes. All right. So f of x is equal to, since -1 works, that means the factor is x plus 1 times, and then this was x to the first, so that gives me x cubed, then what? Minus 31x minus 30. All right. So that second part, is that something that you can factor? If you have a cubic, the only way you've been able to factor them is if they are sum or difference of cubes, or if it is a, if it has 4 terms and you can do grouping. We don't have either one of those things, right? So we don't have the skills to factor this right now. But do I know some possibilities of what the factors would be? Yes, I do. They're in my little green list up there, right? Those are the only possibilities. And I've already taken care of both of these. So I need to keep going and use this, which came from here, and then I can try another one. Now, think about this. Let's think smarter, not harder here. That if this is negative, that means I have to have a positive and a negative somewhere, right? Those are going to get multiplied multiply together. So I know I've got some opposite signs going on. And then I can, all right, so I've got the -1. I'll just go ahead and stick with all the negatives. Like I don't have to go negative, positive the whole time. I know at least there's going to be some other negative in there that's going to work. So if I have that -1, then I can go to -2, right? We'll try that one. And that gives me 1, I'm starting with 1, 0, because I'm using this, to just use this one, makes it a little smaller, minus 31, and -30. So try 2, see what happens. So -2 doesn't work. So I could try +2, or I could go ahead and jump to -3. Let's try -3. 0. -3 work? No. So can I try -4? No. But what can I try? -5. Or I could do +3 if I wanted to, but we'll try -5. It works, right? Thankfully. All right, so that means that f of x is equal to, I had that x plus, can't lose him. -5 is what works. My factor is actually what? X plus 5. And then I've got this left over, which is going to give me x squared minus 6. Now, can I factor this? Yes, thankfully, because if not, I got to go back to my synthetic substitution, right? So f of x equals x plus 1 times x plus 5, and then I have x and x here. This is negative, so my signs are opposite, and my numbers are 6 and 1. This right here is one of the things that it's really easy to factor, right? But it's also wrong a lot, because you'll put 2 and 3 in there, because 2 plus 3 is 5. Yes, you're right. But if you know the signs are opposite and you put 2 and 3 here, is that going to give you a -5 there? No, it's not. So make sure, even when it's super easy, that you are double checking yourself, because yes, it would still multiply to give you the -6, but it's not going to give you that middle term. And that's where some of y'all are making those mistakes. Now, I'm done writing it, because how should I really write this? X plus 1 what? Squared times x plus 5 times x minus 6. Then I get my zeros, which should be -5, -1, and 6. Okay. Questions? It won't be that bad though, because we need to talk about how we can make some smart decisions along the way, so we're not just testing absolutely everything. All right, so let's look at number 10. At least on number 10, again, your leading coefficient is 1. That's good for your possibilities, right? My possibles are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 16. All right, so we'll start with 1. 1, -1, -12, 28, and -16. Okay. 1. What? Dang it. Oh my gosh, I sure did. I forgot an 8. Thank you. Dang it. Plus or minus 8. I'm just going to put it at it's not in order. Good catch. Good catch. All right. So 0, -12, 12, And does 1 work? Woo, finally, 1 actually works, right? 1 hasn't worked in anything we've done. All right, so that means I got f of x is equal to x what? Minus 1. And then I've got x cubed minus 12x plus 16. Can I factor that? No. I mean, it's factorable, but you can't factor it by just your factoring skills. So I've got to go back and try some other ones. But let's think about what's happening before we do that. I'm going to have to have 2 numbers that they're going to multiply to give me a positive number. They're going to have to be the same sign. So both positive, both negative. All right. So the signs would have to be the same, right? But I know there's going to be 3 things in. But since this is negative here, I know I'm going to have 2 negatives in there at some point, right? So if that means I'm multiplying negatives, like this part is what we're talking about by negatives when we multiply this in here, right? If this is negative, then my actual 0 is what? Positive. So I've got a couple positives going on. I'm going to stick with positives here. So I've got, because I have more positives than I would negatives in here. So this was 1. I could try negative 1. I can also just go ahead and go to 2. I'm going to use this reduced form right here. 1. All right, so I bring down 1, 2, 2. Oh, thankfully it works, right? All right, so then I've got x minus 1. Since 2 works, that means the factor is what? X minus 2. And then this right here gives me the rest. X squared plus 2x minus 8. Is that easy to factor? Yes, thankfully. So I get x minus 1 minus 2. And here, this is our opposite. 4 and then as x minus 2 y times x plus 4. My 0 1 and 2. Okay. Not all of them are going to be something that you've got to do times, okay? But you know logically what to check. Go along. Remember to double check that it's actually in that list. On your assignment, I think that I gave you, well, I'm not sure that you always have enough room, so you may have plenty of room. It also depends on how big or small you need to use a separate sheet of point. That's fine.